Okay, so for the next chapter that we have, chapter 3, all we're going to be doing, or a lot of what we're going to be doing, is working in a new system of measuring different degrees on the unit circle, and that's called radian. Now, what a radian does, or what it really is, it's a unit to measure the angle by the intercepted arc length on the unit circle. And I know that we've talked about this in geometry, you might remember. But an arc length is like a linear distance of how far we're going around a circle. And really what that is then is a piece of the circumference. So let's say that we have our unit circle here. And our circumference is always represented by the formula 2 pi r. And on the unit circle, our r value is 1. So the circumference of this unit circle then would just be 2 pi. So what we're going to do is take the circumference that we have and kind of convert it into degrees. So since our circumference all the way around our unit circle is 2 pi, and in degrees all the way around our unit circle is 360 degrees, we can say that 2 pi is in radians what 360 degrees would be in degrees. So our radian would then be 2 pi. And we can come up with like a decimal approximation. So if I type this into my calculator, I would get 6.283 for an estimate of that. So even though radians is usually written in some sort of terms of pi, so 2 pi around our unit circle, it's okay if it's not. If it's written as a decimal approximation, that's still in a radian measurement. It's not in degrees. It just doesn't look like our typical radians because it doesn't have a pi in it, but it still does because 2 pi is still written as, or can be written as, this decimal approximation of 6.283, and so on and so forth. So this would be then like 0 radians at the start, just like it would be 0 degrees. And I go all the way around my circle and I get back to 2 pi or 360 degrees. So halfway around my unit circle would be 180 degrees, but in radians then it's halfway around 2 pi, which is just pi. So 180 degrees would then be equivalent to pi, and that is 3.14159 or 3.142. So likewise then at 90 degrees, we're halfway around to pi, so this would be pi over 2. And that equivalent is 1.1571. We can type that into your calculator and get that approximation. And down here at the bottom, we would be halfway between pi and 2 pi. So halfway between 1 and 2 is 3 over 2, so 3 pi over 2. So we can also represent then like any radian measurement then, or any degree in terms of radians too, not just our normal quadrantal angles. This one's a little bit harder to actually represent because it's not one that we normally know, but we can kind of set up some sort of proportion. So if I know that 360 degrees is equivalent to 2 pi, so this would be like the whole, I want to figure out like what it would be in radians, so I'm trying to figure out what it would be on the bottom here out of 50 degrees. So 50 degrees on top, radian measurements on the bottom. So it could cross multiply and solve. So I'll get 360 equals 2 pi times 50. Oops, x. And then I would divide both sides by 360. And I just want to reduce that real quick because really this proportion will hold true every single time. But I can reduce this 2 and this 360 and get pi over 180 times 50. And that, if I reduce it down, 50 over 180 will be 5 pi over 18. And if you actually find that radian measurement, 5 pi over 18, type that into your calculator, you'll get 0.873. Now I wanted to specifically write it like this in this way because that's an important way to like figure out how to convert from degrees to radians, because that will always end up holding, like you don't have to set up this proportion every time. Literally this multiplier here will always end up coming into play when I do set up my proportion, or because I set up my proportion every time the same way, that this pi over 80 will always be there when I convert from degrees to radians. So if I want to convert from degrees to radians, I multiply by that multiplier of pi over 180. And then likewise, if I want to convert from radians to degrees, instead I'm going the other way around, so I would multiply by 180 over pi, or I would divide by this number, which is the same thing as multiplied by the reciprocal. Again, a lot of times we write our radian measurement in terms of pi because it's easier to see like a fraction around our unit circle, but don't freak out if it's not. Like, it's okay if it's written as a decimal approximation. That's an okay thing that we can figure out too. Okay, so we're gonna practice these first two by converting our degrees to radians. Now we should be pretty comfortable knowing what this 45-degree angle would look like on our unit circle, and we should be pretty comfortable coming up with our sine and cosine for that. So what we want to be comfortable with at the end here is to figure out what this would also be in radians, and also have the same comfort level with figuring out, well, at 2 pi over 3 radians, it's also this this sine and cosine value, because each radian measurement has a degree correspondence, and we know now what those degree correspondence will give for our sine and cosine values, so we want to group them together and be just as comfortable with radian measurements. So we are going to convert a few on the front and the back, and then hopefully that by the end here, at the end of like the next week or so, we're really comfortable just working in radians rather than just thinking about things in degrees. So again, if I want to convert some sort of degrees to radians, I have to multiply by pi over 180. So I'm going to take pi over 180 times 45. So I get 45 pi over 180. And this is something that you could, like, if you could figure out what that decimal approximation would be in your calculator, just reducing this down. This one's kind of nice because 45 does go into 180 4 different times. So 45 divided by 180 is really 1/4. So we could represent then 45 degrees as pi over 4. So like I said, normally this is our 45-degree angle, and we know that this is our sine and cosine that's corresponding to that. This would be our angle of 45 degrees. But now this is really our pi, or our angle that we're actually looking at is really pi over 4. And most of it's really, like, the pi over 4 really is the intercepted arc. So this is our unit circle. What that pi over 4 is really this length. But it's saying that we're at this, it corresponds to an angle measurement because we're really like an eighth of the way around our unit circle, which would be like 45 degrees of the entire 360 degrees. So we use it to correspond with a angle measurement. So I'm labeling it here as an angle, but it's not really necessarily that angle. It's just, this is my pi over 4 measurement. But it's still like pi over 4 would have a cosine value and a sine value of still root 2 over 2, just like 45 degrees does. So we're going to go backwards. We're going to convert 7 pi over 3 2 degrees. So to do that, we multiply by the reciprocal. We multiply by 180 over pi. So in this case, our pi's are going to cancel out. Our 180 and our 3 will reduce down. This will be 60. So we'll get 7 times 60, which will end up being 420 degrees. So if I wanted to come up with like a coterminal angle, I could. So if I subtract 360 degrees, I'd get 60 degrees. So again, like 7 pi over 3 would correspond to like this reference triangle. So at 7 pi over 3, we would still have like a 60-degree reference angle, but this would be at that length. And our sine value, so I could say like sine of 7 pi over 3 would be root 3 over 2, because it's the same thing as a 420-degree angle, which has that coterminal angle of a 60-degree reference angle, which would give root 3 over 2. So that's kind of where we're headed, is to, instead of having like a degree measurement here, is to actually evaluate at a radian measurement. One more, this one's a little bit different because it's not something that is in terms of pi. So we're going to convert this decimal approximation of degrees into radians. And usually when we deal with a decimal, then in general terms of speaking, it's okay to give a decimal approximation for a radian measurement. Usually if we're given a whole degree, we want in an exact terms of a radian. But for this one, since we're given a decimal to start with, it's really hard to actually find that. So again, when I'm converting from degrees to radians, I multiply by pi over 180. So you can take a second and type that into your calculator. And we'll round to like the nearest, I don't know, 3 decimal places. And we should get 0.423. Okay? So like I said, we have radian measurements that correspond to these angles, and we can still evaluate it in the same way. So what we want to do for these ones is to convert since we don't really know, we're not super comfortable with these yet, we're going to convert all of these into degrees and then evaluate. But what we want to do at the end here, we're going to fill out this entire table, and this is something that you should know and memorize. Okay, so I know that looks kind of overwhelming, but I'll teach you some tricks too to kind of go along with that, so you can get a little bit better at memorizing not just the quadrantal angles, but also all of the angles that are in between, all of our 30, 60, 90 triangles and 45, 45, 90 triangles, and the radian measurements that correspond in each of those quadrants. So again, we're going to convert this. So if I have my radian measurement to convert to degrees, I multiply by 180 over pi. I always like to remember, like if I'm trying to remember whether I'm multiplying by 180 over pi or pi over 180, when I have a degree measurement, I want a pi to be there, so I want my pi to be in the numerator. If I'm already dealing with a radian measurement, I want my pi's to cancel out, so I want a pi in the denominator. And this one, if I take 180 and I divide by 6, I'll get 30. So I'll have 5 times 30, which is 150. So really, cosine of 5 pi over 6 is equal to cosine of 150, which we should know how to evaluate. 150 degrees is in quadrant 2. 150 degrees gives a 30-degree reference angle. So this would give a cosine, or sorry, the sine value of 1/2. And then my cosine value then of negative root 3 over 2. Okay, same idea for the tangent of 4 pi over 3. So I'm going to take that 4 pi over 3 and convert it to our degrees. So multiply by 180 over pi. My pi's will cancel, which is good. My 3 and my 180 will cancel or reduce down to give 60. 180 divided by 3. And 4 times 60 is 240. Okay, 240 degrees is in quadrant 3. We should be pretty comfortable with that. Figure out that reference angle. I could do 240 minus 180, and I should get 60 degrees. So that'll give negative root 3 over 2 for my sine value, negative 1/2 for my cosine value. I'm looking for tangent of 4 pi over 3. So that would be my sine value over my cosine value. If I do negative root 3 over 2 divided by negative 1/2, I'll get a positive value. My 2's will cancel, and I'll get positive root 3. And last one here before we start to fill in our table, we're going to evaluate the sine of 3 pi over 2. So I'm going to convert that, 180 over pi. My pi's cancel. My 2 and my 180 will reduce down. 180 divided by 2 is 90. 3 times 90 is 270. That's a quadrantal angle, so I'm down here. My sine value at that This is at 0, -1. So my sine value at 270 degrees, or in other words, 3 pi over 2, is going to be -1. Okay. So again, what we're working towards is to be comfortable not having to actually do this step, and just know that 3 pi over 2 is a quadrantal angle of 270 degrees, and know that the sine value is -1. And I know that takes a lot of work, the whole idea of memorizing all that stuff, but I think that there are definitely some tricks that come into play when we look at all of our unit circles, or look at our unit circle and all of our special right triangles in there, and seeing some patterns with our radian measurement. So like I said, I'm going to fill in our quadrantal angles first. So here's my unit circle. Missed a little. So I'm going to start with 0 degrees, and we already filled this at the top, that I'll have all the way around is 2 pi, halfway around is pi, so halfway around to pi is pi over 2, and halfway between pi and 2 pi is 3 pi over 2. I'm going to fill in my degrees too, so that we can just compare. So this is 0 and 360, this is 90 degrees, 180, and 270. So there's all my quadrantal angles. So 0 degrees is 0 radians, 180 degrees is pi, 90, missed that one, is pi over 2, and then 270 is 3 pi over 2, and then last but not least is 2 pi. So you'll notice as we go down our radian measurements here down our table that every one of our quadrantal angles is going up by 1/2 of a pi, which makes sense because if the whole thing is 2 pi, then 1/4 of it would be pi over 2, or 1/2. So that's what's happening every single time. So every time you see a pi over 2 or a straight pi or 2 pi, then you're at a quadrantal angle. So that's like one of the first patterns that you can notice. If I look at 30 degrees, so I just want to convert that real quick just so we can kind of see this pattern forming. Oops, did it the wrong way, you guys. Multiply by pi over 180. My 30 and my 180, so my zeros will cancel out. 18 divided by 3, in other words, is pi over 6. So at 30 degrees, here's my reference triangle here, I would get, so it'd be at pi over 6 here. I would have this 30-degree reference angle. And that actually happens with every 30-degree reference triangle that we draw. So if I draw the other one over here, I'm still going to be at some form of pi over 6 at that point. Now, to figure out how far we are, if I am looking, I like to think about it as like fractions. So if I have pi over 6, and then I end up here at another pi over 6, if I add another pi over 6 down, or 1/6 and 1/6, I get 2 pi over 6, which is just pi over 3. And then I'll get add another pi over 6 on. Then I'll have, so 1/6, 2/6, 3/6 will give me the pi over 2, 4/6 will give me 2 pi over 3, and then another 6 will give me 5/6, and then the 6/6 will give me pi. So these are all going up by 6 around our unit circle, and every time that we have a pi over 3, we have a 60-degree reference triangle, and then every time that we have a pi over 6, we have a 30-degree. So at 30 degrees, I have pi over 6. At 60 degrees, I have pi over 3. At 120 degrees, that's my pi over 3 that's located in my second quadrant. So this is 2 pi over 3. At 150 degrees, that's this one here, my 30-degree reference triangle. It's given some pi over 6 in quadrant 2. So that will be my 150-degree reference angle. If I add on, so this is 5 pi over 6, this would be 7 pi over 6, and that would be a 30-degree reference angle in quadrant 3, so 180 degrees plus 30 degrees is my 210, so that's 7 pi over 6. If I add on another pi over 6, so 7 pi over 6 gives me 8 pi over 6. That reduces down to 4 pi over 3. That's my 60-degree reference angle then in quadrant 3. So 180 plus 60 is my 240, 4 pi over 3. If I add on another pi over 6, so this was 8 pi over 6, I get 9 pi over 6, which reduces down to 3 pi over 2. Add on another pi over 6 gives me 10 pi over 6, reduces down to 5 pi over 3, which is my 300-degree, 60-degree reference angle in quadrant 4, which is 300 degrees. And then finally, my last one, this was 10 pi over 6, so this is 11 pi over 6 for my 30-degree reference triangle in quadrant 4. So again, I like to think about it as all of this broken down into 6, but also if you can remember that like the pi over 3s, so here's my pi over 3 values, they're kind of like hugging my x-axis, or sorry, my y-axis, so all of my pi over 3s here, all of these are producing those 60-degree reference triangles. So you can remember if where those are located, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. That should help you at least remember that the over 3 is giving 60 degrees, and then over 6 actually gives 30 degrees. So it's kind of opposite from what you'd think. And then the 45 degrees, we already converted that at the front. So here, those all give pi over 4 values. And that makes sense because if this is pi over 2, it's halfway in between 0 and 90 degrees. So halfway in between 1/2 and 0 is 1/4. So I have pi over 4. This would be 2 pi over 4. This would be 3 pi over 4. So pi over 4 is my 45 degree, and then this is 135 degrees. 3 pi over 4. 4 pi over 4 gives pi. 5 pi over 4 is our next one. That's a 45-degree reference triangle then in quadrant 3. 6 pi over 4 gives 3 pi over 2, and then our last one is 7 pi over 4, which is our 45-degree reference triangle in quadrant 4, which is the 315. And then 8 pi over 4 gives us back to our unit circle. So all of the pi over 4s correspond to 45-degree reference triangles, all the pi over 6 is 30 degrees, and all this pi over 3s are 60-degree reference triangles. And so you can kind of use it in that regard. You also can maybe think about it as like 30 degrees is smaller than 60 degrees, and so is a sixth. A sixth is smaller than a third. So you can kind of think about it that way, that like as we go up our unit circle, as we go up these parts, our fractions are getting bigger because we're adding onto our arc length. We're getting more and more around our unit circle, getting closer and closer to 2 pi, so our fractions should be getting bigger in that case. Either way, whatever method that you use, and if you want something else, I can try to help you kind of remember this a different way, but you do need to memorize all these radian measurements, or at least be able to reason them out, all these like radian and degree conversions for all these special right triangles. You're going to have a quiz next Tuesday. It's a timed quiz. You'll get, I gotta double check, but I think like 3 minutes to fill in a chart. It won't be in this order. It'll be all mixed up. Some of them will give the radian measurements, and I'll give you the degrees, and they'll all be like mixed up around, so you have to be able to fill that in like 3 minutes. And again, like some of it is really fast to fill in, some of it takes some thinking. There's definitely strategies, but that should be done by next Tuesday. And again, that's our big idea here, is to actually, we're like comfortable drawing our reference triangles for our degrees now. Now we have to be comfortable drawing our reference triangles for our radian measurements. So that's where we're headed, in which if you can memorize the radian measurements, or at least get a good feel for them now, which is why I'm asking you to spend some time actually and and memorize them, then your life will be easier in trig, because the rest of the time that we have, the rest of the semester, we don't really deal with degrees anymore. We mostly deal with radians. So it's important to get a good grasp on it now.